Hello everyone, in this tutorial I'm going to show you how to generalize or how to do simplification of line features using the weighted area algorithm. So you can see we have our data here, which is the world data, and the world boundaries data. So since the boundaries data is in form of polygons, I am going to convert these polygons into lines. In which manner? In such manner, go to Windows, search polygons, just type polygons to line features, and then double click onto this area. Onto this table, input the feature that you want to be converted into line, which is the world boundaries. So just click OK, then close that. This polygon has been converted to lines successfully, so I shall close the world boundaries data and now generalize these word lines, since we want to simplify line features in form of line using this algorithm of weighted area. So we shall go to generalize, we shall go to toolbox, then go to cartography tools, then go to generalization tools, then go to simplify line. Click there, then input the feature that you want to simplify, which is our world lines. So shall go and input the algorithm of weighted area. Then the simplification tolerance. We have seen from my past videos that the weighted area or the simplification tolerance, the smaller the simplification tolerance, the higher your data is not distorted. So for me, I'm going to start by using 0.1, but I shall use another simplification tolerance of our value which is higher than 0.1, so that we may identify the difference of the course. So I shall click OK. So there are some algorithms which are running, so let us wait for the layer panel on the weighted area to be added. So our layer is here, so I can turn off the word line data. Then we are left with this one, which I've undertaken simplification using the weighted area algorithm. So let us identify the difference using, for example, here in Madagascar. Let us turn on the initial data, which is word lines. So you can see this algorithm. You can see the effect of this algorithm here. For example, this area that has extended at this point has been converted, or it has been assumed, or yes, these are the effect of weighted area, where the points are multiplied with their weight and the one with the smallest weight is removed. So you can see for weighted area, the points are multiplied with their weight, and one with the simplest weight, for example this one here, is removed. So let us see effect of weighted area. So this one here, when we turn off this initial one, we shall see the effect of weighted area here. So I shall turn this one off. So you can see the weighted area, that area was initially here, has been removed, since its value or its weight was small. So that's how the weighted area algorithm is or behaves. So let me now use another simplification tolerance. So I shall turn off this layer and open the initial layer. Then I shall go to App Toolbox. Then I shall go to Cartography, Generalization, then Simplify line. Then go here, input the before one, then go to weighted area, then put a tolerance, for example, of 10. Then click OK. This is just for identifying the difference. So let us identify the difference when the algorithms of adding this layer to our working sheet or to the layer panel is complete. Okay, let us wait. You can see this layer is being added here. So this layer has been added here. It is here since we had opened. You can see this is the initial data. This is weighted area with simplification tolerance of 0.1. Then this one is with effect of simplification tolerance of 10. So let us see the difference here. By zoom, we can zoom in. You can zoom in, for example. You can see with the weighted area, or in generalization, these algorithms, as the value of simplification tolerance increases, much of the data is distorted, since when I turn off the initial data, you can see that, for example, here in Madagascar, much of the data that was surrounding this area has lost. So compared to this algorithm when simplification tolerance is 0.1. So you can see when simplification tolerance is 0.1, this represented in green is much better, or much of the data is not distorted, which is this one. Let me turn off the simplification tolerance of 10. So you can see the simplification tolerance of 0.1 is almost equal to the data that was there. But since weighted area with the smallest weight is removed, for example, this one here and this one here, we can conclude at that point. So feel free to follow for the next videos. I am going to use even QGIS to make now final touches on this generalization using the simplification algorithms. Feel free to share, like, and subscribe. But you can convert your data into PDF from the second tutorial. Just refer there, or you can go to File, Export Data, or Export Map. Then, and to this point, you shall give the file name, for example here, then save your file in the format that you are going to use. So for example, me, I shall save in PDF, then I shall use the resolution of 300 so that my data or my work shall be clear. For example, when you use 150, much of the data will be lost. I can show you even how to label these features. For example, you can come here, then right click onto this point, then click label features, and you can see your features will be labeled, but these labels are much, they might distort, or they might make the data become inaccurate when the scale is too small. So or when the scale is too large, so you can use a smaller scale so that this text can be visible. So I shall put all this word data and then save my work. So thanks for this tutorial. Feel free to like, share and subscribe, friends. Bye.